Okay, this video is going to cover the first half of section 1-4, which is average rate of change. The average rate of change between any 2 points on the graph of f of x is the slope through those 2 points. So what we're talking about is we're literally going to be using our slope formula from algebra. The average rate of change, or AROC, for any 2 points is y2 minus y1 over x2 minus x1. So for instance, here on this graph, if we wanted the AROC, the average rate of change, over the interval -4 to 0, okay, notice what we're looking at there, -4 to 0, and in reality I should have rounded brackets on these because these are simply domain intervals. Okay, I'll just use the square brackets, I don't think it matters. We're looking at the average rate of change between the points where x equals -4, that's your x1, and 0, that's your x2. So right here is the second point, right here is the first point. So notice that at -4, our y value is 0, and at 0, our y value is +4. Okay, another way to write that is that f of -4 is 0, or f of 0 is 4. Remember, those notations mean the same thing. So what we're looking at here is we're trying to find the average rate of change between those 2 points. Those are -4, 0, and 0, 4. So we simply do exactly what we did in algebra class. We apply the slope formula. The average rate of change is y2 minus y1 over x2 minus x1, or 4 minus 0 over 0 minus -4. So the average rate of change for this particular example would be 4 over 4, or 1, on that interval. So hopefully this is a nice, easy thing. Again, what we're doing here when we're finding the average rate of change is they're giving us an interval, a domain interval. So those are our x's, x1 and x2. So we need to find the function values of those. So we start with f of -2, which would be -2 cubed plus 3 times -2, which would be -8 minus 6, or 8 minus 6, meaning that f of -2 is 2. Remember that that implies the point -2, 2 is the point we're going to use in our slope formula. Then we need to find f of the second x value, which is the other endpoint, -1. So that would be -1 cubed plus 3 times -1, which would be -1 minus 3, or 1 minus 3, which is -2. Which means f of -1 is -2, and implies the other endpoint that we're using is -1, -2. Okay, again, from there, x1, y1, and x2, y2, and then all we have to do is find the average rate of change on that interval, which would be y2 minus y1 over x2 minus x1, or -2 minus 2 over -1 minus -2. That is -4 over 1, or -4. Let's do another one. Might want to pause and give it a shot. Okay, let's assume you didn't pause. We have, again, 2 x values. We need to figure out what the y values are that go with them. So g of x1 is g of 1. We plug 1 in for both of the x's, and we get 2/7. That implies that g of 1 is 2/7, which means we have the point 1, 2/7 to use in our average rate of change. G of x2 is g of 4, or 4 plus 1 over 4 plus 6. That is 5 over 10, or 1/2. So g of 4 is 1/2, implying the point 4, 1/2. Now, as ugly as those numbers are, it doesn't change what we do. We have our x1, y1, our x2, y2. Our average rate of change is y2 minus y1 over x2 minus x1. We have calculators. This should not be an issue. 1/2 minus 2/7 over 4 minus 1. Now that would be 7/14 minus 4/14, which would be 3/14. 3/14 over 3, meaning that the average rate of change, feed that to your calculator, is 1/14. We can do the same thing from a graph, okay? And we don't need to stress about this. You are fully capable of doing this. Again, our interval is giving us our x values, our domain values. So we have x1 and x2. We look to see where on the graph those points are. When x is -1, we are at -1, 0, because f of -1 is equal to 0. At x equals 3, our function is up here at this point, okay, the point 3, 4, because f of 3 equals 4. So we are finding the slope of the line segment that connects those 2 points. Okay, we're finding that slope from there to there. So our 2 points are -1, 0 and 3, 4. And all we have to do is our average rate of change, x1, y1, x2, y2, and we do the slope. The average rate of change is y2 minus y1 over x2 minus x1. That is 4 minus 0 over 3 minus -1, or 4 divided by 4. So the average rate of change on that interval is 1. That does it for average rate of change. On to the next part.